Hmm. I think we're live. Hello, everyone. Uh, so I'm back. Today I will be starting a new development blog because I think it is useful to start documenting the things as they come. So let me show you what I wrote today. So today I'll start blogging more regularly using this page. Feel free to do the same for your UXM blogs, projects, or documentation if you want to use Uxntal. It is for everyone in the community. So the to-dos I'm currently working on is the Send testing framework in Uxntal. I need to finish the extended methods to assert the working stack and return stack depth, as well as recovering from imbalances. Let me just test the audio is working. Mm, Let me just test the... Yes, it is working. Okay, so also I have this project for the cat jam. It's the Uxntal Koans. I need to add the repository. I already did all this. Well, not all this. I still need to add colorizing to the output, but I added a lot of tools that will be very useful for the Uxntal Koans. And then I'm also been working on Bake. Bake will be like an Uxntal make version, but for UXN, using the UXN CLI 11 emulator specifically, because this emulator has a subprocess API that allows us to spawn subprocesses as childs and check the status, wait for them to exit. So it is really neat, and I want to use that to do like sort of occidental scripting, and I have just figured a way to do this. I'm very excited. Then for me it's still the same day, but I will be using UTC, and I just want to... I don't know why it says UTC here. I just want to state this once. Oh, there we go. Yeah, I needed to refresh the page. So time is in UTC, so it already changed apparently, but I have added a new article for Linux integration, and this is very, very interesting. So it turns out that we can make the ROMs and the TAL source file executables under Linux and probably under other Unix-like environments. So let me explain you how this works. Oh, I'm sorry for the movement of the mouse. I will need to make this like displays a lot slower. But anyways, so in order to register a Barbara ROM, for this to work, your code has to follow the convention of setting the system metadata device port, which is 06 byte, the byte 06, as the first thing in the onReset vector, so that the assembler emits the expected magic numbers at address 0 in the output file in order for the system to recognize this as a proper UXN Barbara ROM file. And we can check here. I put a link for the definition of the metadata convention. So here it says metadata exposes additional information about a Barbara ROM. A program's metadata can be found by forming a 16-bit address from the second and third bytes of a compatible ROM file. A compatible ROM must begin with A0, which is the opcode for lit2. Then a 2-byte address. This can be whatever 2 bytes, that can be whatever they are just ignored. And then the subsequent 3 bytes should always be 80 hexadecimal, 06, 37 hexadecimal. So this is lit, the device port 06, and the DO2 instruction. Okay, and then here we can see later, but this is a very basic example. So here metadata is this pointer to this label, and here it's just that the version of UXN is 0. I believe it will always be 0. Then we have the fields of the metadata separated by this new, well, in this case, this only has one field, which is text. Then it says here fields 2 for version and text. And then we see here like the Barbara version is 56. So this tells us what is the supported Barbara version. We can look into that later because here is the link. And then 83 is a 24 by 24 icon, and then we have more things, right, that we can manifest in this metadata. But the important thing here is that these bytes here can be used as a magic number by the operating system to recognize them as a UXN ROM. Okay, and then we can do things once we know it is a ROM. So let me go back to here, and let's see how this works. So we would need first to register Uxntal, the emulator, to run these files. Okay, in this case I'm running Uxntal, not Uxntal 11, because Uxntal by default is sandboxed, and also this one doesn't have the subprocess API. It is very important that you know that you can shoot yourself in the foot, because later on we will see that we can actually run we could run a command that trashes your host operating system, just like you can do with any other programming language. Okay, so that's all we need to know. But of course, I also want to try to make a Uxntal emulator that does have the subprocess API, but is also sandboxed, so that at least it only works on a directory and below. And if we screw something up, it will just only be there. We cannot risk like I am doing right now. But I mean, I'm not doing anything crazy, okay? So what we see here is that we are going to send the contents of this string. Well, it is just the standard input to this configuration file called binformat.d uxn.conf. Okay, and what it says here, it is the A0, the lit2 instruction, then 2 zeros here which are ignored, the lit instruction, the device port, and DO2. This would be the magic number, and here we have the mask. So it is only taking into account the first byte, the fourth, fifth, and sixth. The second and third are ignored, but this has to be the pattern that needs to match. We can check that the file was created successfully, and in my case, Uxntal is in home snufkin bin Uxntal. Okay, so now I restart the service with system control, you will need to use sudo to do this. Just restart systemd bin format, and then we can check that in proxies fs bin format, I believe this is miscellaneous, uxn. Now we have enabled. The interpreter is home snufkin bin uxnkli, flags, offset, and some other stuff, right? So this is the mask and the magic number. The offset also 0, so this has to be at the 0 offset of the ROM file, and that's it. That is how the system works to recognize this metadata. So now here I'm just printing, outputting the bytes and saving this in test.rom. And what it is doing is just it's simulating when you call meta, the pointer. So it is just a lit2 instruction, 2 zeros. Then the system metadata device port with the lit instruction, so it is pushed to the stack. The do2 instruction here. And after that, we can put whatever we want. That would be our program. So in this case, I'm just pushing 42 to the stack and then running the debug routine. Okay, so once we do that, we can see also that the file command, I'm not doing anything for this to work. It already works because someone about 2 years ago made this possible. So now we can just run file test.rom and it will recognize it as a Barbara UXN ROM with metadata at 0. Okay, at address 0. And so just by doing this, we already can see, for example, in our scripts, we could know if a file is specifically a Barbara ROM. And also with what we did here to create this configuration file and restart the systemd bin format, now we can just make executable the ROM file and use this syntax and it will run the file immediately. Okay, so let me show you in my terminal here. Let me just adjust the screen. Okay, so I am going to make a directory. I believe I already have one in source, specifically for docunauts. No. Okay, make dir docunauts. Okay, so we are in this directory. I am going to create the file. So I'm going to call it test xrom.file. And the first thing we need to do here is, let's say we have our metadata here. Remember, the first one is the UXN version, and then we can have here something like test ROM. And this 20 hexadecimal is just the space, and then we put 00 to null terminate it. And here at the beginning we just say meta 06, which is the device port, do2, and then let's call 010e do to see the stacks and break. Okay, that's all we need to do. So we save it, and now that I have saved it, let me just assemble it. Okay, and now let me run it just to check it is working. Okay, there it is. This is the normal way we would usually run the emulator. In my case, CLI is just an alias to Uxntal, so I don't have to type that long. And Asm as well is just an alias to Uxntal running the driftlim assembler in Uxntal. So that is the assembler, that is the emulator. But now what we want to do, if we check the current directory, here it is our emulator. We can use file test.exe.rom, and now it is wrong. Let me see why. Because, for example, maybe it is just that I did something wrong, but this here is I have tested this. So with this we are creating now a test.rom. If we dump test.rom, we can see that we have the A0, then just whatever it is here doesn't matter, delete with the device port and DO2, and then whatever comes next is our program. Okay, so if I run file test.rom, then it recognizes it as a Barbara UXN ROM with metadata at address 0. Let's dump real quick the test exe. I don't know what happened. Okay. That's very weird. Let's take the example from here. Maybe I don't want to waste much time. Maybe I just made a silly mistake. Okay, and here before breaking, I want to print the stacks. And now we assemble test, but what it's called? Like this. Reference invalid. Why on reset? Oh, maybe it is. Yes, there needs to be a space there. Now reference invalid app icon. Okay, so this is just not like a full example, but now it is assembled. We can check if now it is recognized to be a Barbara ROM. Okay, so if you see, all the files here are printed in white, so this means that they are not executable. So if I would try to run test.rom like this, I get a permission denied. But if I change the permissions of the file to add executable, now I should be able to run the UXN ROM directly just by registering this magic number. Okay, just by doing this and restarting the service. But now we can even go a little bit further, because we could also make the actual TAL files, the Uxntal source files, not the ROMs, executables. And this is how it would look. So we go to register Uxntal files, and this says this works by making a shell script be run on the file using the shebang feature of your operating system. So here it says save and make this file executable as uxn somewhere in your shell's path environment variable. And this is a very simple, let me just move, expand, no. Okay. Yes, it is very annoying. So now it won't bother us. Okay. So now that we have this, so this is just a regular bash script. This is the shebang, and it says set the emulator and the assembler. Here we just set some environment variables to where I have the Uxntal and Uxntal. Okay, the assembler. Then we compose the output drum file dir name. So basically this is just so we because Uxntal needs, for example, if I say just asm, okay, it doesn't asm, weird. Okay, so let's say I don't have driftly. We can do Uxntal runs driftly. Okay, maybe it's a change, but it used to print like the usage, and the usage is basically you need to say the test file and the ROM file. Okay, so what the code here is doing is just taking the test the .tal file, extracting the base without the .tal, and then adding the .rom for us. Okay, so that's all it's happening there. Then we create a temporary file, okay, and we are going to put the contents of our Uxntal script minus the shebang, okay, because the shebang is not valid Uxntal syntax. So if we would just try to run the file as is, it would not run. Okay. So for example, we can try this using the uxn bot. If we try to run something that looks like this, it says it thinks it is an invalid number. Okay, so we need to strip the shebang from our script and then assemble it. So here it is just trying to assemble, else it fails. And if it succeeds, it finally runs the Uxntal emulator here with our produced ROM. And this ROM is assembled in the same directory. So it is the same behavior as normal, as if you were running all these steps manually. Okay, so this is just a little bit of automation. But as I said, if you are going to start using the UXN11 emulator, you need to take care of not shooting yourself in the foot, but you are completely responsible for that. I mean, any other language can do these stuffs, okay? But I feel compelled to tell you this because there is evil in the world. So, however, also just as a parenthesis, I don't like the sandbox. Okay, so I am willing to run my scripts on a virtual machine and have a snapshot, and maybe if it breaks, it's okay. Even if I lose data, I can just roll back to a snapshot. at least until it is pretty safe, because I even want to go as far as using a REPL made in Uxntal as the system shell, sort of. Okay, so just see how far it goes and when it breaks, and then maybe we can uh, do some things to it to make it a little bit usable. Um, I have already tried making a REPL before, so I have always wanted to come back to this and make something better than the first time when I was learning Uxntal, which I'm still learning. Okay, I'm not a professional at this, but I just like to play a lot with this. So in order to test this, I have already done this in my computer. I already have this file, so I have this alias cat uh, that it will show me everything in colors. It is just like cat, this the normal cat. So we have cat, and I have my stuff in being, oh, what it's called, just UXN. Okay, and this is the same file that we have here, minus the comments in the wiki. So now in order to test, we need to create a file with the shebang. So check this out. This is very cool. We are going to open again the file we had, the ROM, the tal, but now I am going to put a shebang. Okay, I just put this user bin and uxn. I save it. Now let me quit, and now I can just make, okay, see, if I put ls, we can see that I made the ROM file executable, but now we are going to make the tal file executable. Okay, so we are going to chmod into test xrom.tal. And now if I see again the listing, we can see that now the test xrom.tal is executable. So now let's try running it, and it works. Okay, so this is really great, because now this means that we don't actually need this script right here. We can make the, or maybe we run into a chicken and the egg problem. So, but anything after this could be completely Uxntal scripts. We wouldn't need to do any more bash scripting. So let me see. This is running this file, but we already can run a ROM. No, I think this can be bits all the way down. I put it here also in the log, because I want to play around with this idea of being able, if you didn't know, the UXN CPU, it's sometimes called a bit. So I want it to be as much as possible as I can in this playground, only UXN, and see what are the limits of this environment. Okay, so let's start doing that. First, we are going to make this script, a Uxntal script instead of a bash script. Okay. Then we are going to assemble it, make it executable, and just put it exactly where this file is currently. But we will have the other. Let's test if it works. It would be cool if it does. So in order to do this, let me close OBS, or just, yeah, there we go. Then we can open Sublime, let's create a new file, and let's it's still not nighttime, so let's put the theme to light so everything matches. Okay, so we are going to check. I currently have a stub of this in Bake. Bake Bake currently is not a thing of its own, but I have a demo in the Uxntal Koans. So if we go here, we have this bakefile.pal. What is this? Let me make this a little bit bigger. So this bakefile basically is already a UXN script. Here it is using a library called arcs by DM, which is a very prominent Uxner. So this library allows us to send a callback and a function callback and a vector. How would I say? And a vector handler for start and input to this initialization function called arcinit. And this function will take care to parse the arguments. So when we do full bar bus here in the terminal, this would be the command, and everything here are the arguments. And this library is just helping us to access these arguments in a more ergonomic way. So in my case, I don't need the standard in vector, so I'm just setting an empty vector. What I care at this moment is the function callback that I have here. What I do is I check the arc count by loading this counter here, and then I check if it is greater than 0. So in this particular bakefile example, we only want to accept one file. If we run full bar bus, this would be an error. And actually, let me change to that directory here. cd Uxntal Koans, and I have it here. Let's see. Right now, I have also a wrapper called bake. This is a fourth script. This is in G4. I don't know if this can be colorized here. Yes, okay, there we go. So this is a fourth script, and it is basically just calling, creating the bin directory, compiling Uxntal, and then assembling the bake file. Once it assembles the bake file, it passes the arguments. All this is just to pass the arguments to this command bin Uxntal bake file. Okay, and then it is run, and we check the return status, and then we run this word called bake. Okay, so now that I have this knowledge of how to run Uxntal scripts, I don't think we even need to use for, because the idea of the Uxntal Koans is to use a concatenative languages. Of course, the Uxntal emulator is in C, but everything besides that should be, at least, well, I set that goal, should be a concatenative language. But instead of using Fort and having to install gfort, because this could also easily be a shell script, but instead of using shell or using gfort, we can use 100% Uxntal to manage our build project, and also running the make clean and make that. And let me just teach you how this would look. So right now in bin I have these drums that I assembled, and let me now, I could run, typically you would run something like make clean, okay? But now we are using on our own stuff, and we run make clean. Oh, bake clean. Oh yes, we have to put the syntax. And don't worry about this. Right now it is the same issue we had. Let me just turn on the lights. So this is the same issue we had before, where the hash bank is not part of the Uxntal syntax. Okay, the audio is still working because sometimes it fails, but we are going to fix it. Okay, so let me, for example, if I remove the hash bank from the bake file, let's just put it in a comment for now. And now we can run bake clean again, and as you can see it works. This is the fourth script. This is the argument, and I pass this clean argument to the bake file. Okay, we can see that it removed the bin directory that was here. Okay, we had this bin directory. It removed that, and then it also built the ROM file. Okay, so right now it is very simple, okay, because it always builds the ROM file, but then it just deletes the bin folder. But for example, if we don't pass the option, it will just assemble it, try to run it, and create the bin folder again. Okay, it assembles a version of Uxntal, so we don't have like an external dependency. I will put Uxntal here, and that way we only run bake, and we have our emulator, we have our bake file, we have everything we need. Okay, so we can run again bake clean. We see that it works, and then here in bake, okay, so right now this is just the way I used it. So right now we only accept clean. We can add more commands, so that is the idea. We will add more commands that the bake file, so for example, when we run bake, it just assembles and doesn't complain, okay? But we can fix that in a moment. What I want to do right now is make the bake file itself executable. Okay. So let me just think a little bit about this. What is what I actually want to do? How do I want to accomplish it? Because I wanted to mimic like the bake file and the make command, but in our case that would be two different things. So I guess to deviate from the original make, and this is also pretty common as well if we just run a shell, a build .sh like this. I'm sorry for my English. So if we have a build, this is also pretty common setup. I just very recently started using make. I think it is useful, but maybe we don't want to have the make API yet, because we are starting, we just want to have something like build.sh. Okay, so let's do that. We are going to rename bakefile to build.tal. Then we are going to make it executable, and we are going to enable the shebang again. Okay, now I don't even need to assemble it manually. I in theory I should just be able to use build, and there we go, it works. Okay, so now I have Uxntal scripts. That is very, very cool. It automatically assembles this, and it will build the ROM in the same directory and the build ROM sim in the same directory. Maybe we can adapt that. I don't think that is... We can make the clean also remove this for now. But it would be better if this is just put in bin. But for now it works. Let's keep this simple. And I am very happy because now we don't need the bake file at all. So let's see, what is the bake file doing? Bake here. So let me put it here side by side. And here I am going to open where is it? Uxntal Koans. I want to open I changed the name, of course. So here is our script. Okay, and let's see what the Ford is doing. So this is the fourth code. Let's see. It makes the bin directory, so let's do that. Let's add a new target. So I am going to make a sort of domain specific language, the same way I'm doing for the testing framework. So this will be a domain specific language, but we still don't know what is the exact pattern we want to have. So we will just experiment. For now, we have a targets object with the name of the target. So we have clean, and let's say we have build. Build can be the default, but whatever. So for now, oh, we can actually do that with the R count. Okay, so if the R count is more than one, we go to usage. If the R count, and we can actually make this like a function, but let's just keep it that way for now. If the R count is 0, then I want to do the code here. Else, if the R count is 1 but is not greater, I want to run the rest of this code. Okay, so this code just gets the first argument, duplicates the pointer, and then it will compare it to the target's clean string. If it is the same string, then it will run here the command clean. Okay, and this run is provided by this library, by bake.tal. So we can abstract all the library code from the domain-specific language, just like we did with the testing framework. Okay, so now we have the clean here. Now we want to check as well. Well, actually here I'm not doing any cleanup, but here I would still have the string. So I can do something like targets, build, compare it, and then here we run commands build, run. Okay. Okay, so now we have two options. So let's put also the option here in our documentation. We have build and we have clean. This is now called just build.tal. Then we have we are running here. Now we have to run. Okay, so here is build, the terminator for the string. Let's make a little bit prettier this. So these are our targets. These are the commands. So we have the clean command, and then we have the build command. And the build command is going to first do this. So it's going to say. Also, I have recently found a way that I like to use the, instead of using this literal row, I mean this row space here, I like to do now like this. And I don't know, to me it is just easier to write, it is more readable. So that's what I will use. So it is the same, I'm just putting spaces here. So the first command is to create the bin folder. Then we are going to compile the Uxntal emulator. And I don't know how long the command can be. So I guess I'm going to be using subcommands just to keep it simple, okay? So this one is going to be, what happened? Oh, it is nighttime. Okay, so let me change this as well. So where were we? Let's make this a little bit more more granular. So this will be the command to. Okay, so this will be just bin. We have to null terminate it. So this is the bin command. Now here we have the cc command, but this is a valid hexadecimal, so I need to put it in uppercase. And we have cc space here, space, terminated. Okay. So first we create the directory, then we compile the emulator. So the next step here was to compile the bake file, but we don't even need to do this anymore, and we don't even need to do this part either in order to call the bake file that is now this same script that is the build script, and we don't need to make any of this. So all this script was doing just passing the argument and these two commands. Okay, so now we can remove that. Let's also make the clean command a little bit more useful, because right now it is only doing that. So we are going to remove the bin directory, but we are also going to remove. Oh, I guess I can do it in the same line. Okay, so we remove the bin directory, and we also remove build.rom and build.rom.sim. Okay, so that is the command. And this is the one that creates it. It assembles again, and then this one will actually yes, because here I actually ran the bake file here. But let's see now what do I want to do, because at this point it is running itself, so I don't need to do anything more here. Let me just try to format this way. Okay, so we have a build command. So now we are going to actually build the first file that we have here is, so if we go now to source, if we go to lib, we have the testing framework that I will be using to make the koans. We will see shortly what this is all about, the bake file. I guess this can still be called just bake, okay? And then we have the args library by DM or D6 in Mastodon. So that is it now in lib. Oh, we just opened that. In Etsy we have the driftlim, the symbols, and the Uxntal. And here in source we have our first test suite, and I still have to update this to the new API I developed, but it will be even more readable. So now the first step is to try to assemble and run this file. Okay, so we are here in the bake file, and let's call this, well, this is just build. Let's have another one that it's called run, and run will be just I guess we just need to change the mode. Chmod plus X for source about assertions dot tab. Okay, 0 0. Okay, so this is just this just makes it executable, and then we have to actually run it like this. Okay, and here I guess we need another space and do this. So we are making executable, and then if that succeeds, we are executing it, just like that. Okay. So I guess build just has to be like this, a space, and this. Then it falls through to the next command, but then we can like specifically just call cc. Okay. Or let's actually call this emu. So this is the emulator, this is the bin folder, this is run, and let's call this clear. Okay. Now okay. I wanted to have like the same length, but this is fine. Clean, build. Let's have more commands. We have bin, and we have also the target emu. Build, bin, emu, run, and clean. Okay, and run. Okay, so those are all the targets. So now let's put here build, clean, bin, emu, and run. And probably let's just put run the first. And then we will see, just make sure dependency order is correct. Okay. So we can either run, build, clean. I guess bin is just not that useful. Or create the emulator. Okay, let's just keep it in with this. Run, build, and clean. Run, build, and clean. Okay, perfect. Okay, let's make this more compact to make it a little bit more readable. Now that we know what we want. So these are the commands. Let's put run first. Run, build, clean. Here as well. Okay, so it just keeps the order. So we have the messages. Okay, the library. Now the usage function just prints the usage and exits. Okay, so that's all it does. We don't need this because we can just flow through here to the usage here. Then we jump if it is greater than 1. If it is 0, we are going to run build. And then we are going to run. Okay. So first we run this command, then we run this other command. And here we are returning. We are exiting. so it doesn't matter what is below. So this is for the run target. Here below we have okay, so here we just did this. Here is the first, let's put the build target, and then we will have the clean target. Okay, so now let's just swap this. We first want to build, and here we just want clean. Then we fall through. Here would be like error usage, and here it's as well an error. Okay. Oh, but yes, we also need to put here the target for run as well. So this will be built. Okay, let's just update this real quick. Now this will be built, and this will be the run target. So that way run is the default here, but we can also explicitly request it. Okay. So that should check out. Okay. I think we can test it. And it should probably do what we are expecting it to do. So let me just build this here. Number invalid. Okay. Let me try to do it first manually. So we have the build is already executable. Okay, so now nothing is happening. Or maybe we are, well, I am screwing my computer. I don't know, could be. Oh, that is running the that is trying to run the, let me see. What were we doing again? Run is trying to run the assertions. Okay. That should fail because we haven't updated that. So let's test the build. Commands, targets. Okay, let's test with clean. Clean works. Okay, so now we have something different. So that is good. So usage build. Okay, let me see. We need to debug. What are we getting here from the arguments? But it should work. I mean, it was working, right? Oh yes, I don't have here the null terminator. Let's try again. Okay, let's create a macro here for debugging. Okay, so now what I'm going to do is just trace this. Here when we finish arc init, it should be, let me see. Okay, and I'm going to add another macro, like with an exclamation mark. That just calls the bug and then we exit. Number invalid. Oh, okay. I understand now. So this is from my build tool here. Okay, it seems I would have to do this for the build tool environment I had here for it to work, because yes, so my current environment for Sublime does not recognize this thing that I put here. So I will have to do it on the terminal. Okay. So let's first run that. So here the stacks are perfectly what I expect. And now let me just put this here, and a little bit like this. Okay, so this is fine. But then I want to see what is what we actually get here. We just duplicate this and we are going to log the string. Okay, and of course I think I don't have that function, but it is very easy to implement. So let's just put it here. The log string function is it takes a string pointer, returns nothing, sorry. It will check if the first byte that is loaded is 0. If it is, it pops and exits. If it is not, it prints, increments, and jumps to this stir label, sub label, and that's it. So let's run this again. Oh, and of course these are null terminated, yes. Okay, so it printed here clean. Okay, so that works, at least. We could even make these yeah, basically clean works. So up to this point we have the correct string, but now we are here. It should fail. It should give us a 1 so that we can jump. Yes, we jump here, and then here we have a 1 again, so it should jump here. But here we should have a 0, and then here we have an error. Okay, let's see. We have targets clean, targets peels. So the error is here. Let's try to isolate this. Let's actually just run and then return so that we can debug here. Okay, so that means let's see if this is the branch that is jumping. Okay, so we are not jumping here. So that means it is jumping all the way here. Mm, there we go. So yes, the error is here. But I didn't change anything from the library. How could I have messed it up? I just changed this. I just added more targets, more commands. Maybe the command is failing. Let's just do the remote open till bean. Okay, so what is happening is that here we have an unbalance. Let's see. But if we check here, and you know what? We don't actually need to test the strings. We just need to test the pointers. So yes, because I think this string compare is buggy that I made. Oh yes, so we need to duplicate again here. Silly, yeah. Okay, so we are debugging this part. This one. So let's simplify this and just do is targets run the same as. Oh no, but we don't have the like a pointer. We would need to. Um, no, we already have the pointer to the argument here. So this is the argument and run and include the book. It is not reaching that part. So now I did something else. Okay, so it is falling here. Oh, okay. The arc count is 0 based. The arc count is 0 based. Is that it? Okay, arc count, load absolute. In let's actually see what is the arc count first. Yeah, that it's a little weird. Yes, the arc count is 0. Okay, let's save this. Oh, Control Q. Let's save this. Let's stash everything. Now we have bake here. We just remove this to make it work. Number invalid. I already saved. Oh, this is built. We need to go back to bake file. And we are going to comment this. There we go. So that works. What did I break? Let me see here. The arc count. The arc count here is 1. Okay. So that checks out. Now let's apply the changes again. And boil clean. Okay, so now it expects. Oh, sorry. Now it expects the shebang. Okay. Here is the count. And to make sure, let's just exit immediately. Okay, yeah, so that is the count. Okay. Now if the count is 0, we do this. Else we should arrive here. Let's just see what happens. Okay, yes, so we have arrived to this part. Now we should arrive to this part. There we go. Now here it is a 0. And it just ran the command clean. Which is R. Oh, let me see. Do I have bin? Let's create it. Okay, there it is. So we need to run this. we know that we are going to fall through, so we can move this debug here. Okay, just sometimes I need to make sure I'm not crazy. Okay, so then what is failing here is the run function. Okay, let me see. So we duplicate the argument here and consume it. Duplicate the argument here and consume it. We don't have to duplicate the argument because we consume it. We just put the clean command, which is this. Okay, if I dump this, we can see that it says (01)E7 is the command. It is here. It starts here. Okay, 01E7 is the 7260. So this is the RM, the space dash RF space BI beam space, and we have a 0. So that checks out. That is the, we can even check with sim build.run. Dot sim, yes, in that way. Okay, so targets clean, commands clean is 01E7. So that is correct. Zero 1E7. Then what is the issue? Okay, we need to figure this out. Okay, so there is no other way. We need to go to the run function, because when we exit here, we don't never return. So the problem is in run. But how can the problem be run if we didn't change anything in bake? Is it because now it is running? Let's have another command, echo, and this one just echoes something, so we know if there is actual output. Targets echo. Oh yeah. Oh, we have a viewer. Hey, how are you doing? Feel free to write comments. We are building an Uxntal build tool using Uxntal scripting. So we are not going to be using manually the assembler anymore. But first we need to make this work. So right now I'm having adding the target echo, which will just run this command, and then let's just test here, okay, if that works. Doesn't work. And just to show it kind of works, we can stash this and run this, and this works. Okay, so that is what we want, but currently this bake file is a fourth wrapper. I could have done this with a shell script, but the idea was to use only concatenative languages. So there is no like a concatenative shell that I could install in my system, and I decided to make this in fourth. However, the only things that I need is to create the bin folder and to compile the emulator. Then I would have this bake file that I would just assemble and run immediately, check the exit status, and call the bake file ROM with any arguments I pass to the fourth. So all this is doing is just passing one argument, what you would do with syntax in string interpolation in Bash. So that, for example, when I run this, it would say like bin oxently bin bakefile.rom, and then the target like clean or whatever. So that is what receives ultimately the oxently application. Now I have found a way to have more Linux integration, and the way I'm doing this is I register the Barbara ROMs as executables with this trick. This is in Oxonomicon wiki. I'll just have to make sure to put the link in the video description. But basically this is just registering a convention in UXN where we have these magic numbers at the beginning of the ROM, and then we can recognize that and choose an interpreter to run this ROM. So we can see here in the test, I just create a ROM file with the magic numbers it expects, and also I'm just pushing a byte, and this system debug statement here or expression is just printing the stacks here. So once I do that, interestingly enough, the file command is already aware of this convention of the metadata as magic numbers. So it is recognized now as a Barbara UXN ROM. All I need to do is make it executable and then just execute it, and now we don't have to do the assembly and running, or it just saves us doing oxently and the name of the ROM, for example build ROM, like this, right? That is all it's doing, but we can do it now with just this syntax. And going a little bit further from that, I also found a way to make the Uxntal files themselves executable. So not the ROMs, but the source files. And this is just taking advantage of the shebang feature in modern operating systems. We just need to have this script in the path, and what it is doing is just assembling the ROM for us without the shebang, because the shebang is a syntax error for UXN. And when it does that, it executes the ROM. And here is the test example. We just create a new file. So the interesting thing is that this doesn't need the metadata convention because we are using the shebang. We put the shebang, we just print the stacks with a 42 pushed in there. We make the source file executable, then we execute it, and we have assembled the ROM in the same. Let me do this example so our one viewer can see what I'm talking about. So let's create test.tal, and I am just going to paste this shebang here. This is pushing a 42, and this is just printing the stacks, and then we break. So if I check the listing, right now test.tal is not executable. All we need to do is make now test.tal executable and execute it, and there we go. So now if I show the listing, we can see that it assembled for us the test.rom and the test.rom.sim and run it all in one step. So I think this is pretty cool, and now I want to get rid of the oh, I needed to do a git stash, not git stash pop. But anyway, it doesn't matter because it didn't work. So oh, and it is in another file, so we didn't lose anything. I was a little bit scared. Okay, so now this is how the actual bake file works. Okay, so we can already make the bake file execute itself, but then I started modifying this. So let's go try again. So let's just go right from the bake file. We just add the hashbang. We have the bake file is here. It is not executable yet, so let's fix that. Okay, now it should be in green, and we can run like this. Okay, and it did something. Okay, so that is working. It's telling us the usage. Okay, so if we do clean here, it should so okay, let me think about this. So it failed like that, but if I run and then if I check, that remove the bin folder. Okay. Okay, so let me just see. I think I understand now what is going on. So we have there a bin folder. I'm sorry, I'm getting a little bit confused. There we go. We have a bin folder. Now if we run Uxntal bake file clean. Okay, no, it didn't work. But at least now it's not hanging. Oh, because it is a bake file tile. Yes, so if we do it this way, we need to run the ROM. Now it doesn't work. Okay, so I think I almost got this. I just need to experiment a little bit more because just today I was aware we could do this. So we first are going to assemble bake file. Okay, and now we are going to run it with clean. And now it doesn't work. But if I restore, I didn't delete the. Okay, so we still have bake there. If I run it through bake, and I pass clean, and now I check, and now it deleted the bin folder. So that is working. Let me just double check for my sanity's sake, because I have to. So there is the bin folder. If I run the fourth script with clean, and then fourth is passing this clean argument to the command, that worked, and that removed the bin folder. Okay, so let me go back again and see what is doing the fourth script. And I think there is no fourth support. Yeah, there we go. So we are just creating the bin directory. We are compiling the assembler, I mean the emulator, and then we just run Uxntal driftblin. Okay, so we are building the bake file, and here we just run bake file with whatever, for example, that would be like the actual invocation that is passed as a command, and then is run with this word that is called system. Then with this word we can check if it failed or not. So this is working. Let me see. We don't need this part because now it auto assembles itself with the trick we have, and then it just runs this. Because for example, if we don't run it with system, if we just type it and finish, and let's comment this part here. So here, this all should be correctly commented. Instead of running the command, let's just print it. Then yeah, and that's another problem of Ford is that I don't know Ford. So but why is it an error? I just put here type instead of system. I close the word. So this is, I don't know if maybe this works. Yeah, perfect. So that should fix it. So here we can see, let me put a new line. After I type this, we are going to put a new line so that we can see this is the actual command that is being run. Okay, and this is what is working. So instead of typing it, let's say do type and then system. So we can actually see what is it that we are running. And why it didn't print? Bake system in file included. Okay, well, I don't know what happened there, but we know what is the command that we are passing now. We are not crazy. This is working. And there is no bin folder. So now that we have seen the invocation, let's just copy paste this verbatim. And let's run it ourselves. Of course, we need to do this manually for once. Let's see. There is no... Oh, this is not Uxntal. We need to put the O. Okay, that's fine. It already exists. But it didn't work. Okay, we are just the source file, the output. Why it didn't work before, I don't know. But here we go. Oh yes, because it was changed, so the first one failed. So anyway, we have the Uxntal emulator. So now we can run the command that we have here. We still miss the bin bake file. Ah, okay, yeah, I understand now. I'm so dumb. So with this bake, we are specifically telling it to build in bin Uxntal. And we are putting this in bin bake file. But with the new method, this is all built in the same folder. So when we do, for example, ls-bin, we only have the emulator. And we can assemble the bake file in the bin folder, like this. And then we have now these folders here. But if we run it, the bake file is already executable. So let's remove here bake file. So now we only have oh no, we also deleted the bake file. Let's restore it. But anyway, now we only have the bake file. We make it executable. And we just make sure the shebang is... Oh, I have a lot of files. Okay, now the shebang is what we expect. So now we just have to run it. Okay? And that creates the files here, not in bin. So that is the issue. Okay, so we only need to adapt this. Let's see. So we run this. Oh, but it is this one. Okay, let's first keep this simple with bakefile.tal without any arguments. Now let's pass clean, and that's what's failing. So it is very weird that all the juggling I had to do to pass the argument with fourth worked, but now this that should be more simple is not working. Somehow there is something wrong. The only thing I can think of is, let's compare this file. So let's compare this with running like this. So it doesn't matter that it's failing, we only care about that it assembled. Now let's try to diff bin bakefile with bakefile, and they are identical. So there is no issue with that. The problem is how we are calling it. If we can only make this work, it's going to be very fun to continue doing this. So let me create here the debug macro again. And let me see who is the viewer. Oh no, you can only see when, like when. I'm sorry, we can only see when it's like a like. But anyways, so let me think this through. Here we should have nominal stacks. Okay. So we just run like this. It is complaining that debug is not. Oh yeah, I need to reduce this. Okay, so here the stacks are nominal. This is exactly what I expect. So this is working. So now we are going to check that we are getting one argument. And there we go. We have one argument in the count. So of course one is not greater than 1. So we fall through here. Then we check this. And here is where I printed the argument. We can duplicate the pointer of the string and just print it like this. I already have done this here. So this is the print routine. Let me just check. This should be fine. Okay, let's for sanity's sake, let's just make sure this is not leaking. Okay, this is working correctly. It prints the string. and it is not linking. Okay. So now with this string, we can print this, and after printing, we should have nominal stacks. Okay, we only have the pointer, but it didn't print the string. Okay, so 025F is 025F is panic. So that is what we have here. But why? So maybe that is why it's failing, because we want the first argument and that is that pointer? I don't understand. No, so this is a different pointer. Oh, but because I put more code, yeah. Sometimes it confuses me. But anyways, we have here the exact same pointer. We are trying to print it. But it's not working. So, okay, let me go to another project I have here. It is called Software Tools in Uxntal. I don't have it here. It is in source code, in Git, Software Tools in Uxntal 3. We go to source, lib. I don't know why I called it static. Oh yeah, because it is like pre-assembled here. So we can only copy this pre-assembled routine that is completely relocatable, and this will help us debug this now, because I don't understand what's going on. Let me just delete all this. So I'm going to put this here. Oh no, but not here, sorry. We go back to bakefile, and here I can put my memory routine. Then I want to log the arguments, but let's see how the arguments work. Is from code verify. No, this is plastic idolatry. It's called NXU UXN. Sometimes it's difficult to find these repositories, but it should be called something like actually I have it here. Yes, this one. So here, this is where the by D6, this is where the ARC library comes from, and we have an ARC demo here. Okay, so let's just see. It has a buffer that it's called ARC buffer. Okay, so in theory that means that we can do here ARC buffer. Let's say we want to print one page from the zero bank. And we need to change to the other directory. We were in source. Uxntal Koans. Okay, so now we are here again. We can run this file, and now we have this xdump here. So in the buffer we have the string we are expecting. We have clean, null terminated. Well, everything else is zeroed, but this checks out. So we know that that is the correct string. But now let's see if the thing we have here, arg read, is the same thing. And yes, so arg read is the same pointer. So at least we know that is working. So now maybe the issue is the string compare. If we debug here, we should see that we have two pointers on the stack. So the one we just duplicated, and then we are testing with targets clean. Okay, and then we are going to run string compare. And the string compare here gives us 0. So that means that we pass to this side. Because remember, these are unless. So we should read it as unless. Something like this. And by the way, this is valid syntax. Okay, so I don't know who is watching, but maybe this can help you. I use it especially with syntax like this, and then I would need something like this, and then in the unless you would jump to end, and then you would have here your else, and sometimes it's more readable. But anyway, that's basically what this syntax means. So unless this is 0, we get here. Okay, so that checks out. We are inside the book. Now let's see. Instead of doing the tail calling elimination optimization, sorry, let's just jump normally so we can check what happens after that. And that's the issue. Run is not returning. Okay, So now let's see. Let's see, leave it like this. And run comes from lib bake.tal. So let's. I don't know what is happening because obviously the other way is working, but it doesn't matter. We just need to fix this. And bake is pretty simple as well. Bake is only defining these labels. It has an exit and a panic routine. Oh, it has the string log routine that I just made. Now, sometimes I put log string, sometimes string log, so. But anyway, this is the same routine. Then we have the string compare routine. So this one should be working because this one is taken from the library. I'm also going to put that link. But in the UXN wiki, this is called Ocean in GitHub. We have this software library, and then we have libstring. So from this libstring is where I got. I mean, I have implemented it previously, but it is not as easy to remember that this compare string compare is not as easy as just the string print. Where is it? Well, this is a little bit different, or it's just formatted different. I don't know. This is the same routine. Okay. So this one I already know by hand, but this I don't like to write this many code each time. I copied this from this library. This should work. So obviously now the problem is here. And then this syntax means that we are just concatenating the arguments library. So that is how including works in Uxntal. So let me just think about this. For the person that is on the live stream, do you have any idea what could be wrong that you would like to comment? Mm. Okay. I think I know now. Yes. Okay, let me double check. So in the Uxntal Koans, I put here in it I put Uxntal, but this Uxntal is not the normal one because this one is the one that is able to run the subprocesses, of course. However, the one I have registered, as I mentioned at the beginning of the stream, the one that I have registered to this script is just Oxenclick, but from my home bin. So what I need to do is go to lib, cd2 oxen 11. I have here a lot of junk. Let's just stash it and see if there are any updates. Let's make it. Let's test it. So whenever you build it, it shows you this. Okay, I'm sorry. Let me see that the audio is working. Sorry, let me see that the audio is. Okay, I accidentally hit the sleep button. Okay, I accidentally hit the sleep button. Okay, so this is the demo. Let's not hit the sleep button again. Yeah. So when you hit F1, you can make this a little bit bigger. Now let's make the background music playing again. So all this is working, right? But I don't know if this make actually creates the this Uxntal. I don't know if it's the Uxntal I need. So we need to change to ITC alternative, and this is the Uxntal that I want. So what I'm going to do is just as compile this one, and let's put it in my path. Okay, so now I need to change this registration, this here. So when I put which Uxntal, it is running the other one. So I just need to redo this part. Oh, I always do this. Okay, so copy. So this is going to create this file again. But now instead of which Uxntal, it's which Uxntal 11. Okay. So now if we cat etc bin format uxn.conf, now it says Uxntal 11. Okay, so now this is the one I need. And now we don't need this one. Now we should be able to run this. What was the file we were testing? Uxntal C. Okay, so we were in bake.tal inside run. Right, so let me just put here a debug just to make sure we are reaching there. Okay, if I do file, bake file, so this doesn't recognize as UXN because doesn't have the magic. We are using the hashbang. So it is not this one that we need to fix. It is the UXN, this script now also needs to be updated to use UXN 11. Okay, so if we search which is UXN, it is just this this script, and here we just need to put UXN 11. Okay, there we go. So now it exited, and let me see. So we are creating the bin folder. Then we clear the bin folder. Yes, it works. Perfect. This is so cool. We have Uxntal scripts. Isn't that cool? Okay, so of course, as with everything I do, the problem was very simple. I just wasn't able to notice it. We just needed to change the emulator, and I have to be very careful now because any program here that I run, if I mess up, I can screw my computer. So let's see. In my blog, I just need to make sure to add a setup for setup a VM, just in case. Okay. Oh, actually, I can start putting here the links of the streams so I don't repeat myself. But anyways, I will do this the next time. So with this, we have the script running. Now let's go back to the one that had more code, the build.tal. So in this one, I already have in my callback, I have more targets. I have a run target, a build target, clean, and we were testing echo because we didn't know what was going wrong. But we can still test that one. So this log string, here it is implemented as string log. I don't need it here. I think that should be it. So now let's test with build, which is this one. Okay, so now it printed something. It is giving us the usage string. So that can happen only in two ways, if we jump from here or if we fall through from here. So let's just put here a debug to see which one was. Okay, so we are falling through this part. That means let's pass the echo. Yes, that works. Perfect. So this is the first target that is working. And let's just check after it finishes running. Here, oh, I already have the. So what is this 200 hexadecimal here doing? I think it doesn't matter right now because I just exit immediately, right? Invalid reference. Hello world. Perfect. Then where is the other debug coming from again? That one is from bake here. Okay. And this is how the subprocess work with the UXN11 emulator. All this is running through this little function here. This is an extension of the console device. Let me just highlight here. So we normally have in the console what is the vector. This is the piece of code that is run whenever we type something, or well, to be more specific, whenever there is a standard input that needs to be read. Then here we don't use these 2 bytes for anything. But in the normal UXN specification, if we go to to here. Barbara. If we go here, console, we can see the normal specification has only these ports. Vector, read, then it jumps up all the way to type, write, error, and these ones that are grayed out are the ports for the extended UXN 11 device, or the UXN CLI 11. I don't know why we are missing some here, because as you can see we also have live and exit ports. So the exit ports is the status code of the subprocess when it returns, and live is a flag that tells us if it is still alive. And that's all we need. So we just we pass the command, just to remember how this looks. Where is it? Yes, here. So here we are calling run, and we are just passing the pointer to the command string. That's all it needs. So once we said that this pointer for the command, we store it in the device, and then this is the thing that actually does the fork. There are some times it is not very documented, but I should do it myself in the Uxntal Koans, so I don't have to search for this again, because every time I need this I forget it. But anyways, there are more types. There is not just this 01. I believe there is a type that I could use to capture the output of the tests, and then just buffer the output in memory and do comparisons. Because right now for that I was planning to wrap my framework, my testing framework tests in Python, but that is not nice. I would prefer to be able to run my tests all in UXN, and also be able to capture my own output and make sure, because since that is the output for the testing suite itself, I need to make sure that it fails when I want. But I haven't found like an easy way to do this programmatically. So I need to check visually that the colors are fine and all that. If I do it this way, I could run it in a mode where the standard output of the child is connected to the standard input of the parent of this one. And that way, when I get back the bytes, I can buffer them and then compare them to some other thing. And how that would look, let me also show my only viewer here how that would look. If we go to Mastodon, I put here very recently where is it? Okay, so this one here, let's just open this one independently. No, it's not this one. This one. So I have created this routine now that I showed you previously, but for the testing framework I want to have colors. So I started doing this. Now we have the same routine with the option, because it is a setting. We can say we want colors or not, and that is useful when we want to pipe it to other programs that don't expect the ANSI escape sequences for the colors there. We can just strip those out. but for the human that is reading this, we want the colors. And also here, this is how the test looks. This is the domain specific language I made for the tests. And the domain specific language for the build is also going to be similar. So instead of passing so much pointers, we can have something like this here where it says set. We could pass the command inside the curly braces to the run function. That way we have a counted string, not a null terminated string. We would just, oh, but wait. No, that wouldn't work because it would still expect the null, the terminator here. Yes, but it is not documented. So I think that the command still has to be null terminated, even if we know the length of the command. The API, when we pass this to console adder, it wants a null terminated string. So let's just give it what it wants. Then here we fork, and here we are going to loop, checking the console live port of the child. Well, yes, it tells us if it is alive, and when it is not, then we fall through this one here. We check the exit status, and if there was an error, we exit with the same exit code that the child had. Else, in this case, we just so let me see. If it is 0, it just exits. I hadn't checked this because maybe I don't want this. I just want it to panic when there is an error, but I don't want it to do anything else. As well, this one, I copied this one from another project I have that is called Talos. And this is like an operating system for UXN. This was the first like big project I did. Right now it's completely broken, but it's basically a REPL. It is like a CPM or very early DOS kind of operating systems. Only single user, nothing, no tasking whatsoever. But here I had the option to run this REPL and also change the prompt to a shell prompt like here in Julia. Yes, because I don't think, oh, I actually still have it installed. So let me remember what was I believe it was R. Oh, dang, I don't remember. But whatever, the thing that happened here is that it was like Julia. Julia is another programming language that has a REPL. And in Julia, when you type semicolon, the prompt immediately changes here to shell. And here we can run shell commands. So I can do this in Talos as well, inspired by this Julia. Let me actually try to demo this. But for that, I will need to see what was the actual command that it expected. So this is the REPL. All the other code is the assembler and whatnot. This is just the REPL. And the REPL here has something called shell mode here. So it wants Control N. Okay, if I put Control N here, let me see, micro, which Talos? Okay, micro. Which Talos? Let's put here Uxntal 11 as well. No, I don't know. It is not working. One way we can show you this, just I'm not crazy, this worked. What we can do is, I have another channel that I think I put it here. See my channel. Okay, so this is how Talos look like. Or well, it still looks like. It's just that I don't use it anymore because I want to make it better. But this is the REPL. So here I defined a string and a label. The 20 here, hexadecimal, is the space, then the new line and the null terminator. Then I get the pointer of the string I just created and pass it to a function that is already defined when the environment starts. This function pster is already defined for us. Then here it is working with the, I press Ctrl N there. I believe so. Let me go back here. No, I think it was Ctrl S, or I don't know. I changed that. But anyways, as you can see, I am using Uxntal 11 to run in my REPL. That this is an 100% Uxntal REPL, doing just-in-time assembly of the code. Then I can change to shell mode, and it is even sticky. Like for example here in Julia, when you change to shell mode, it stays in shell mode. So like 10 years ago, I even lived with Julia as my system shell, believe it or not. So maybe now I want to do that, but with Talos at some point in a VM, in a virtual machine, so I don't mess anything. But we could see what happens if we try to use this kind of interfaces as a dual to the host operating system and the guest operating system. I think that's really cool. Anyway, let's see the demo here. Let me remember what that is doing. Oh, so there I am going to create a file with the string and the label. Okay. And if you notice here, I'm making a typo, so I'm going to have to correct this later. But at that moment I didn't notice. So that's the echo command from the system. Okay, I was having a stroke. And then what is going on? Then I just call a function foo that gets that pointer and prints the string and returns. And as you can see, I came back to the Uxntal REPL. I press again Ctrl S or whatever to change, and then I can see that this file test.tal now exists. So now I can cat it. Oh yes, it is not sticky, it is changing back to... At some point I made it sticky. So now this is where this little typo here after the 2.6, it is just trying to redefine message that I already defined in the REPL, trying to redefine it with the source file that it is loading with this syntax. And now we have a sort of syntax error, and I'm going to try to fix it. I go back to shell mode, I go to my micro, open the file, I fix the typo, return to my REPL at some point, there we go, and then I try to include it again. And now this is not an error, this is a warning. I should have used another color, but this is just a warning. And it told me that it redefined these two variables that, well, these two labels that I created in the REPL. And it still works. Now it was just another string. But anyways, so I can have this, I love this sort of interfaces where everything is on the command line, but I don't like to be constrained by the sandbox of the normal UXN emulators. I like to have all the power like with any other programming language. I just have to make sure I don't type anything stupid into the terminal to regret it later. But now I guess let me just contemplate on this, because I think I need to take a walk and just celebrate, because this is really cool. At least to me. Let me just make sure it still works. That is great, that is beautiful. Okay, so there we go, that is the build system bake doing its thing. I think that for Uxntal Koans, I will actually want to call this not build, but meditate. And we are not going to put the extension, because we are using the hash, the shebang. So now we don't really care. We can just say meditate, and it would do its thing. Okay, and that is completely abstracted, that this meditate happens to be an Uxntal script with its hashbang and everything. That's really cool. So the next step is going to be to okay, let's not get rid of this yet. The next step is to check the build, run, and clean. Let me see what I'm doing wrong here. Okay, anyways, I have changed the name, so before I start trying to edit that, let me go back here. So here we have echo is working correctly. Let me also just put here the, oh, that's going on. Jump to R. One final debug here for sanity, just to make sure. Okay, this doesn't work yet. This Uxntal, this one is the one that I need. Echo is working. Let's try first with clean. because this one tried to build and then run. Or maybe I need a separate meditate script for the koans, and this is for the build. Decisions. Let me see. So this echo, this still works perfect. And if we see, this is 0, perfect. Then we want to check clean. Let's see. We don't have a clean yet. Oh yes, I remember now. So we invented echo just because we weren't sure what's going on here. So now we are going to jump here. Oh, but wait. There is something wrong with run because it didn't print the... It didn't print here the stacks. So we just changed this to clean, so it should run with clean now. No. Save. Okay, this is very confusing. We have hello world, but we don't have the debug. All right, I know now. We were speaking just a few moments ago that let me see. That in leap, bake, we don't want to exit. Let's see what is the status here. Okay, so here the status is 0. If it is 0, we just want to return. If it's not 0, then we can panic. Okay, now we have the output we want. Okay, let's go back to meditate. Yes, so here we only have the return pointer that is going to be consumed here. Correct. So this is called, and it is not. I don't actually like this callback design so much. I would prefer to manually set the device vector myself, and I would prefer that when arginit finishes, I can just call myself the callback. Like, I don't want this to be inside the arginit. I'm going to do that later on, but because then I can do whatever I want. This is just a function. I don't care it is working with vectors or whatever. I can just treat it as a routine. So then I would be able to call callback and call debug here to make sure that the last thing that I do is actually what I want. But anyways, right now I think this is working correctly. Now we have targets, echo, echo. Targets, clean, clean. Echo is this command and clean is this one. Let's combine this here. We are going to first print cleaning. This should be inside double quotes. So this is the syntax for bash, not for UXM. So we say echo cleaning, and after that we try to remove this. Let's see if that works. No. Why does... And if I do echo cleaning, okay. Okay, yes, now I need to change here again to clean. Now it doesn't work. So let me just check one thing here. Let's go back here. Let's dump again. Let's dump this. To log name, and then this is the address, this is the bank, and this is the length. Reference invalid. What is the name? This one. No, meditate. Okay, this is starting to get confusing, so I'm going to remove this. Let's just save it. I don't want to regret it later. I can delete it later. Okay. So I think I can close this. No, this I need this one. Test show. I just going to save this one. From none to Tetris. Then here we have extended methods. Untitled. We have send in this one. Let's put this one here. Okay, now we have bake. Ah, yeah, much better. Okay, so the one we were working on was meditate. Here we are going to put the log function. so we can see what is going on here. So here we received echo. So if we pass clean, we get clean. Okay, so that works. Build. Run. Okay, now it tried to run to change the mode of about assertions, so it could run it as a script. So that worked. I believe are all the targets. But again, why is this not finishing? When we had hello, no, when we had echo, that did work. So we need to put here dup2. My keyboard is failing. And here we are going to put echo again for echo. Now echo says cleaning. Okay, so maybe this is what is not working. The double ampersand. We can test by making this here. And then here. Let's just say like we finished clean. Now it says cleaned. Reference invalid echo in echo 44. Oh yeah, I need make this a string. Okay, so that works. So it seems that it doesn't matter, like this is not doing any escaping for us. So once we run cleaning, it goes to run cleaned. Then we put a space, ampersand. Oh, that's it. I needed another space here. Yes, because here I don't have space. That is the issue. Let's go back here. And now it should run. No. Then what is the issue? Where we don't have bin. So let's make bin again. Then we run like this. And then, oh, okay, I know. So in order for us to know we finished, let's put the other echo here. It would be done cleaning or something like that. Done cleaning. Okay, so we run cleaning, then we run done cleaning. So we put Control C and we check, and yes, bin is not there. So now the only issue is that we are still we are not exiting the ROM. Why are we not exiting? Let me see. Let me just think 5 seconds on another thing. We have been streaming for about... I'm getting hungry. I believe it's like 3 hours. Yeah, it's almost dinner time. But anyways, this is how the tests look for the testing framework. We can see here, for example, here I define the test data, these 2 strings. This is just an alias of the other. And then in this section, I log with info level, I log test data. Each section here creates these rulers, and then this show mem routine takes the pointer of a variable, the name of the variable we want to print, which bank, and the length. So in this case, length is 5, the bank is 0, the string is just these pointers, and we pass this to show mem so that we can see during testing what is the testing data we are using. And we could put this under for example, if we are in verbose mode, we show the info. If we are not in verbose, we don't show it. So we don't clutter the output. By default, everything is in colors. If you don't want colors, you have to manually put on colored. And we can see the strings we are using to testing. Then here we see a test that failed, but it didn't fail because they are not equal, because as you can see here, they are equal. This failed for another thing that I will probably fix tomorrow. But anyway, so that is the dump routine. Now oh, okay, I think I know what is the issue. So if we go back to args, args wants as a callback, and it also wants the vector, the standard in vector. This is stored here. So when it finishes, it sets the vector for us. But now that we are here, let's actually change this. This will be a function. We don't want we just want to set 0 here. So we put 0 to the console device. And then instead of calling the callback, we just return. So now it should finish. Oh, then I messed up. Now what happened? This was working. Maybe maybe it's not that easy to change right now, but what we can do is just load this. Oh no, we don't need it. We just need to put the 0 here. Let's just make it easy like this. Okay, let's test again. It's still not finishing. Why is that? So I would expect this to... Yes, so I would expect this to finish after we do that. Oh, okay, I understand now. So we can return from here. Then in meditate, as we said, now we need to pull our callback here. So this doesn't need to be called callback anymore. We still need to pass something to standard in here up until we change this API. But anyways, this callback now can be called, let's say, meditate. Or well, this one is bake, because we are still just doing the build file things. We have not touched the actual koans yet. So I want to have this API arg init bake, and then here I want to run my debug assertion. So in order to do that, we need to call this arg init, and then here we are going to pass just this pointer. Or actually, let's try to fix this correctly. So how many times are we using this? Just here. And then how many times are we using this? Standard in. So this is where it stores the the function and the callback. Call this during the callback. Okay, so we don't need standard in, we don't need the callback. We only need this part. So this is first, this is our routine now. Then it just does this stuff. Once it is complete, it will return yes, here it says a vector, and here we set it back to 0, then we jump. Okay, that seems to check out. Now let's test it. Okay, I think so. So this is not working as I expect, but I think we have made a lot of. So it's trying to run another command now. That's not the one we need. Okay, I'm going to move meditate back to bake. Now let me just make dir back, and I'm going to move bakefile.tal and test.tal to the backup. Then also we are going to move build.tal to the backup. And we are going to remove everything that is a ROM and everything that is a sim. Okay. So we are back at square one. Before anything happens, let's just commit. Experiment with Uxntal scripts. Oh, yeah. Yeah, I need to take a break. Okay. That worked. So now we also move bake to backup. We don't need that. We have bake file, build, test, Uxntal Koans. Okay. So now let's run again. Meditate clean. Oh, now it's called bake clean. Now it's called bake. No? Oh yes, the other bake. I'm sorry. Okay, so now we can run bake clean. We have been there. Okay, but now why bake is trying to run the assertions file? We are trying to run clean, not run. Because when we are in run, we just do commands run. When we are in build, clean, equal. Okay, so this is going to be called. Let's just remove this. Let's call this clean from here. So echo cleaning, then remove and echo done cleaning. Okay, yeah, we don't have commands echo anymore. We don't need to duplicate this. And we also don't need this string. Okay, and again, now it's trying to run source about assertions. So that chmod is here. It's trying to run, not clean. Okay, now we are not getting anything. Okay, but this is just because I just broke the args library. It was working, so this is completely my fault. And I just want to have this because I would actually want call like I don't know, just call it arg parse perhaps, and then we can check what is the buffer, and then we can use it to do whatever we need. I think that is more composable than the callback, especially for a library, because we don't know how it's going to be used. But anyways, I think today was a great success. Uh, I actually got rid of the fourth script. Another thing that would be very interesting is to get rid of this script here. Like we could implement this in Uxntal, right? Because it is just actually it is just assembling and running. It just removes the shebang and then just assembles and runs. That's all it's doing. And if we can make this perhaps not a script, because then we would get into the chicken and the egg problem of who is going to interpret this so I can interpret this. So what we could do instead is have this one pre-assembled in Uxntal in executable format with the metadata magic, so that it can run like just any other binary, and then it can assemble the rest for us. So that will be a task for tomorrow. Thank you very much for watching and for listening. Feel free to leave me any comments and suggestions. I know this is not very structured, so it is not a tutorial. But I hope that when I finish, the Uxntal Koans may be used as tutorial or even as kind of game, because I also had this idea of having a game that this is the game. So maybe you are like in Rogue Byte, the video game. Maybe you control one byte, and maybe this is like the stage, and you can walk on ASCII characters, but you fall like with gravity. You fall for the where there are only dots. Or maybe this could be the playing area and this could be just like a map. I don't know. I think it would be very cool. And just have the stacks and the dump, and maybe a special device here for the health and whatnot. But that would be it. So that is also like once I do the koans, like I think that could be a video game in the future. But as I said, thanks for watching, and I hope I have time tomorrow to make another video. Let me see. I have to put an intro and an outro, but thank you very much again for watching, and have a wonderful night. Here in Mexico, it's already night, so